Okay, so I've got a new Triggerscope Mini here. I wanted to give a brief introduction to this as well as show a walkthrough on how to set up in Micromanager. We have drivers available for Micromanager as well as for Starlight Nebula. More coming out soon. For the Micromanager driver, this is actually just the standard Triggerscope 4 driver with less functions. So this is the new Mini. The Mini is a smaller, more contained version, simplified version of the Triggerscope 4. It has only one USB-C connector, which is kind of nice. No power connector needed. You have status lights for everything on this box. So every light in or out, or every signal in or out, has a light. So that's a nice little feature. Helps to reduce debugging time. We have one trigger input. We have 4 TTL outputs. These are 0 to 5 volt. And then we have 2 DAC outputs. These are 0 to 5 volt 12 bit. Now for the input, this will signal at 3.3 or 5 volts, so it's 5 volt tolerant. It's not going to blow anything up if you send it either signal. So let's take a look at the Micromanager configuration for this. We're going to open up a copy of Micromanager Nightly Build. I'll choose No Configuration. We'll add the devices using the Hardware Configuration Wizard. We're going to have to add a demo camera to this because otherwise we won't be able to do any fake picture taking. So we'll go down and find the demo camera first. Add that. That is not the one I wanted. That's the one I wanted. All right, there's my demo camera. And I'll go down, I'll grab the Triggerscope MM. Right, there it is. We'll add that. For the port, we'll choose the active port. We'll make sure to set the baud rate to 115.2, and we'll talk to it. Okay, it comes back and gives us all the options. So again, this is using the Triggerscope 4 driver. We're only going to choose those functions that can be used by this device. So TTL 1 through 8 and DAC 1, DAC 2. For the range, we're always going to choose 0 to 5 volt for DAC 1 and DAC 2. Cycle through, give this a name. And that's it, we're on. If we look at the device property browser and we scroll down to the Triggerscope control, we can now see that if I turn on TTL1, I get a light here on TTL1. Same thing with 2, 3, and 4. Now the channels beyond that won't do anything because there are no TTL outputs for those channels. For the DAC, I can bring the light up here, and what you see is DAC 1, I'm about 2.5 volts. That light will change brightness based on the output, which is pretty nice because I can tell if this thing's working. Now for a multi-channel configuration, say to drive 2 LEDs or 2 lasers, we'll build in a couple groups. So I'll make a channel group. For the channel group, I'm going to choose, in this case, I'm simulating, let's say DAC 1 is for brightness of LED 1, DAC 2 is for brightness of LED 2, TTL 1 is for on-off state of LED 1, and TTL 2 is on-off state for LED 2. So in that case, we want to have the TTL 1 through 8 state enabled for the change in LED channel that will be turned on. I'm also going to turn on the blanking, which is going to be TTL 1 through 8 blanking here, and we'll hit OK. Now in this simulated example, the DAC can just be constant on. We're not going to worry about blanking. We'll give this a name like channel 1. I'm going to go ahead and turn blanking on, and we're going to set channel 1. All right. So if I enable channel 1, why don't I have any LED output? Well, the reason for that is the input here is not on, and we've enabled blanking. So I'll turn on a 5 volt source here using a function generator. And now we can see that the function generator is cycling about 3 hertz, and we have the channel 1 output cycling along with it. If we now add a new preset for channel 2, we can now see that channel 2 is cycling with the input blanking. We go back to channel 1. Pretty straightforward. So relatively easy to get the TTL outputs to work with blanking inside of Micromanager without really having to do anything else. As long as the camera's off, shutter's not open. We'll add a couple more groups here. We'll just add DAC1. We'll call this like... oftentimes people will name these with the thing being controlled. So we could call this, for instance, let's call this 480. Okay, and then we'll add a new one. Call this one like 560, say. So this will allow us to control our DAC power. And so now, if I go to my 480 power and I turn it up, we'll see that the power is responsive. If I bring my 560 power up, same thing. And it's kind of running independently of the blanking. If I really wanted to, I could blank the DAC. So for people that have, for instance, an input that's analog only, you can turn on DAC blanking. So I'll turn those on just to show it. Let's see here. Make sure I'm on the right row. DAC blanking is on. And then you can see already that it's flashing. And then if we turn on DAC2 blanking, once again, follow the row there. We can see that now DAC 1 and 2 are blanking to the input. So this is a way of getting power control without having a TTL input if you need it. And you can see it does blank to the appropriate power levels. So there we're just getting a little bit. Kind of grab that and show it. You can see it gives you just a little bit of output. And again, on-off state. So this thing's quite fast. It's going to run about 10 microseconds, maybe 5 microseconds. I haven't profiled it extensively, but I did try to optimize the code to respond quickly. This is going to be as fast as that microcontroller can go, well below your exposure time limitations. And that's pretty much it. It's a simple device. We're selling it for $1,500. You can buy it on the website store at advancedresearch-consulting.com. You can also find it or information about it on my website at austinblanco.com. And finally, you can also find this available through numerous dealers in the United States, Australia, Europe, Japan, Korea, and anywhere else that you might buy a high-quality microscope. Thanks for your time.